All right, welcome to 1.2. By the way, you'll see the standards that we're going over in front of each of the lessons. So the top standard, A.RE1.1, that's an Algebra 1 standard. And so is A.CED.4, that's an Algebra 1 standard. And then we're also covering 8th grade standards at the same time. You'll see those in front of every lesson. So there's a bunch of two-step equations. Solve them. Show your work like I asked you to in 1.1. So there's the constant on the same side that x is on. We're going to subtract 12 from both sides. We have x divided by 8 equals 16 minus 12 equals 4. That is step 1. Step 1 is always going to be adding or subtracting. In step 2, x is being divided by 8, so we multiply by 8 both sides, and you can write that any way you want, but don't just put an 8 there. And so the only number that would make that original equation true is 32. Do the rest if you haven't. There's the constant on the same side, so it's minus 2, so we're adding 2. So 27 equals negative 3x. In step 2, we have to divide both sides by the exact same number, and that number in this case is negative 3. So x will be equal to negative 9. 27 divided by negative 3. Number 3, we're subtracting 4 from both sides. X divided by 2 equals 12 minus 4, 8. X is being divided by 2, so we multiply by 2, both sides, and the only number that will make this equation true is 16. Number 4 is what we're doing today, and not every 6th and 7th grade teacher goes over that, so let's see who knows already. So if it's plus 4, you subtract 4 from both sides. Everyone should know that, and that's 1/2 times x equals 8. Now, how do we get this what is the coefficient of this problem? It's 1/2. How do we get rid of a fraction coefficient? Well, we said that when x is being multiplied, right? When x is being multiplied, you divide. So we divide by 1/2. But when we divide fractions, what do we actually do? We leave the first number the same and multiply by the reciprocal. So that's what we're going to do here. Instead of dividing by 1/2, we're going to multiply by the reciprocal both sides. So what's the reciprocal of 1/2? 2. Now you could write it as 2 or 2 over 1. That's your personal preference. But we're multiplying by the reciprocal of the fraction coefficient. So we're going to multiply both sides by that. And again, you could write those both as 2. Let's cross those out. All of this crosses out. And you get x by itself. 1/2 times 2 equals 2 over 2 equals 1. 1 times x is x. And so 8 times 2, or 8 times, right, you could sit there and put all these 1s over there. That's a waste of time. But no matter what, x is 16. 1/2 of 16 is 8. 8 plus 4 is 12. 16 was the only number that made this true. So we're going to be solving two-step equations that have fractions and negatives. We did a little bit of that the other day. Well, let's look at the green equation. What is the coefficient of x in the green equation? Well, the coefficient's the number multiplying x. So what number is there? Right? The number there is negative 1. The coefficient there is negative 1. That's what's multiplying x. What's the reciprocal of this coefficient? If that's 3/7, how would you say the reciprocal? The reciprocal of that is 7/3. You say the top of a fraction normally, the bottom of a fraction, the denominator is said like the order of a race, right? 3rd, 4th, 5th, 6th. The exception to that is halves. We use halves instead of seconds. All right, so we're going to find the solution to here. So we're going to check if x equals negative 7 is the one and only number that makes this true. Remember I said that some algebra teachers make you do this on every single problem. I'm just going to have you do it on this screen. So we're going to put -7 where x is, and we're going to see if that makes it true. -5 times -7 is 35. 35 minus 6 does not equal -42. So the answer to this is no. It is not the solution. Right? 35 minus 6, I believe, is 29. All right? So that is not the solution. Now, you could go find the solution, but that's not what I asked. So check this. We're going to put -7 where x is. Right? 3 times -7 is -21. 12 minus -21. Does that equal 33? 33 equals, this is 12 plus 21. Yeah, 33, I ran out of room here, equals, whoops, 33. Yes, so -7 was the only number that made that true. And that's how you would check your work on a test. Say you'd done all your work, you wanted to make sure that you got the right answer. You could put it back into the original equation and see if it makes it true. Let's try one more here. So 3/7 times -7, because we're still doing x is -7, minus 15 equals -18. Now, if you don't know this, when you multiply fractions, right, this is 3/7 times the fraction -7 over 1. You can cancel these 7s, right, top and bottom, same number top and bottom. And so that becomes -3. Now we have -3 minus 15 equals -18. And so -3 minus 15 is the same as -3 plus -15, also -18? Yes. So -7 was the only number that made it true. It is the solution. Okay? You can always check if you've gotten the right answer to an equation. All right. The symmetric property states that if x equals y, then y equals x. This sort of looks like commutative, but commutative is about addition or multiplication, right? Right? This is sort of a silly property, but it's the reason, right? Some teachers are always telling you that you have to switch it around, that x has to be on the left. That means they do not know the symmetric property. Something that's symmetrical is the same on both sides. Equations are symmetrical. So when you do this problem, you subtract 8 from both sides. -2 minus 8, same as -2 plus -8. -10 equals -4x. Divide both sides by -4. -10 over -4. Two negatives make a positive, 10/4. But then you simplify, you get 5/2. It does not matter. So which is the correct solution? They're both correct, is the point. Now, I don't make you, I'm not going to quiz you on the symmetrical property, like knowing the name or knowing how to spell it. But you have to understand there is this property. It says both sides of equations are symmetrical, the same. They are not different. All right, so this is about removing fraction coefficients. The problems on this screen will always have a coefficient, the number multiplying x, that is a fraction. So step 1 will be the usual. If it's add 6, you subtract 6 from both sides. We have 1/2 x equals 10. In step 2, we have to multiply both sides by the reciprocal of 1/2. Flip it over, times 2 over 1. This all cancels out, and you get x. That's 10 times 2, whether you put the 1s there or not. The only number that would make that true is 20. So let's practice that 3 more times. We're adding 3 to both sides. 12. Now notice I left a little space here. Why? Because I'm going to have to put the reciprocal in there. So the reciprocal of 1/5 is 5. These cancel out, and 60 equals x. Try this one. All right, the constant on the same side is -9. So we're adding 9 to both sides. 3/5 x equals 21. So what's the reciprocal of our coefficient? The reciprocal of 3/5, let's use a better color, is 5/3 is how you say that. So we're going to multiply both sides by 5/3. Now, hopefully you remember how to cancel. Cancel this and make it simpler. Yeah, you could multiply 21 times 5 and 1 times 3 and get that. But you'd have to simplify the fraction. That's not what we do with multiplying fractions. When we're multiplying fractions, we can simplify it right there. 3 divided by 3 is 1. 21 is also on the 3 times table. 21 divided by 3 is 7. So now this becomes 7 over 1 times 5 over 1, also known as 35. So x is 35. Let's try another one. So there's the constant 5, so it's a positive 5. So we're subtracting 5 from both sides. 23 minus 5, we're going to borrow there. And 13 minus 5 is 8, and 18 equals 2/3 x. Right, I left a little space there, maybe not enough. Reciprocal of 2/3, 3/2. That's how you say that. That is, let me write that out for those who didn't have a teacher who taught them that. That you say that as 3/2, plural of 1/2, and you multiply both sides by 3/2. So the 2 cancels. 2 divided by 2 is 1. 18 divided by 2 is 9, right? We canceled there, cross canceling. 3 times 9, 27, equals x is the solution, the only number that would make that equation true. All right, so we saw this when into the introduction. When you see the opposite of x, the coefficient there is -1. So solve this. All right, we get rid of the constant by adding 5. Now when I'm actually doing these for myself, at this point I'm going to write -1x equals 13. Why am I going to do that? Because I get students on tests who give me the answer -x equals 13. Yeah, but you haven't found the solution. You're not done, right? I need x, not the opposite of x. And so you need to divide both sides by -1. Now, I'm going to tell you, some of you on a test are going to get questions wrong because you left -x as your solution, or opposite of x. I don't want the opposite of x, I want x. You have to take that extra step and divide both sides by -1. Now, some teachers at that point multiply both sides by -1. Totally works, except I like to, since x is being multiplied, I like to be consistent and divide, right? That makes more sense to me. If x is being multiplied, you divide. So we're subtracting 7 from both sides. 5 minus 7 is -2. All right, so I'm going to put my -1 in there and then divide both sides by -1. -2 divided by -1 is +2. Right? This was 5 equals the opposite of blank plus 7. And the only number that made that true was +2, right? -2 plus 7 equals 5. Okay, so now I want you to solve this equation, and you're going to notice that subtraction symbols automatically turn into negative signs without you really doing anything. And let's see that. All right, so this is +14. How do you get rid of that? You subtract 14. It has nothing to do with that over there, right? And please, that's a +14, so we're getting rid of it by subtracting it. And then, so what do you have now? You have -4x. That turns into -4x without you doing anything, right? One is an operation, one is a sign, but it works out every single time to be the same, which is very nice. 34 minus 14 is 20. In step 2, we're dividing both sides by -4. So x equals -5. The only number that can go in there is -5 to make it true. +5 won't make it true. Try this one. So you're getting rid of a -7. That means you have to add 7 to both sides. The -3x becomes -3x. 8 plus 7 equals 15. Divide both sides by -3, and x equals -5. Coincidence, had the same answer as the last one. Try it again. We're subtracting 9 because that's a positive 9. 14 minus 9 is 5. 5 equals negative 2x. This minus 2x turned into negative 2x. Divide both sides by negative 2. Okay, so we're getting fraction answers. So what could you put here? You can put negative 5 halves. Please don't leave the negative sign down there, though. That's not a thing. So put it out front or back up top. Here, or you'd put it up front, I think. And you can stop there. That's simplified. If you really feel the need because your 6th and 7th grade teacher made you always do this, that's not a rule of math. That's a rule that your teacher had for you to practice. And yes, you could also do negative 2.5. All of those are solutions to this equation. So here the constant is 10, so we're subtracting 10. 4 minus 10 is negative 6. Minus 1/2 x becomes negative 1/2 x. All right, I should have left a space there because I'm going to have to multiply both sides by the reciprocal of negative 1/2. What's the reciprocal of that? Negative 2. It's got to be negative 2 or I can't cancel the whole thing out. So we're multiplying both sides by negative 2. I'm crowding myself here, so let's get that out of the way. So I'm multiplying both sides by negative 2. Negative 2 times negative 6, positive 12. All right, we're at the practice. Do all 4 of these, and then check to see if you understand this before you go and do your homework. Yes, 3 goes into 39 13 times, so 13 times 8. 3 times 8 is 24, and so x equals 104. Right, the coefficient is negative 1 there, so I'm writing it in. So the answer is not 5. The answer is negative 5, also known as the solution. When you solve, you find a solution. Occasionally you'll catch teachers, even me, saying solve for other things than equations. Right? Solving is for equations and for inequalities, if you know what that is, but not for expressions. Expressions are evaluated. Only equations and inequalities are solved. Solve, subtract 12 from both sides. Negative 3/7 equals, that's negative 15. Reciprocal of negative 3/7, negative 7/3. Now, one of the things you've noticed, whoops, there's an x somewhere, right? Where is it? Right there. And so x equals, notice the canceling. It's always going to be there in Mr. Ben's problems. I don't want you to sit there and do 15 times 7 and divide by 3. That's a waste of time. We're learning how to solve equations. So there's always going to be this canceling here. Look for it. So negative 5 times negative 7, positive 35. That's a positive 6, so you have to subtract 6. This minus sign goes with the 2x. It has nothing to do with 6. Nothing. Negative 7 minus 6, that's negative 13, right? Because it's the same as adding negative 6. So negative 13 equals negative 2x. Divide both sides by negative 2. All right, so don't leave it that way. You're not allowed to do that. 2 negatives make a positive, so 13 halves is the correct answer. 12 halves is 6, so this must be 6.5, and it's also 6.5. But you don't need all of those. You just need one of them. What property says that x equals negative 8 is the same as negative 8 equals x? All right, that's the symmetric property, right? It says the two answers are the same. All right, so you're going to put negative 3/4 in there. Now you could solve the equation the normal way and do this, but that's not what I'm after here. I'm after you putting negative 3/4 right there and then doing the math. So that's what I'd like to see in the homework. The 4, we're multiplying 4, and this 4 is in the denominator. 4 divided by 4 is 1. This 8's in the numerator. 8 divided by 4 is 2. So we have negative 12. 2 times negative 3 is negative 6 minus 6. Negative 6 minus 6, same as negative 6 plus negative 6. Yeah, that is the one and only solution.